Okay. So, we are back again. So, I hope you have understood this. So, whenever you will draw phasor diagram, it should be an RMS value, keep it in your mind, do not take your peak value, right, do not take, it will be, and the way I told leading, lagging, little bit understanding is required in AC circuit. When you have understood this, now everything will find too easy, right. So, next is this is this you have an exercise is given to you, you find out I1 minus I2 by both methods, two methods I have shown, and answer is also given here. This is your exercise, you will do it, right. So, now expressing the current in rectangular or polar form, right, the whatever this thing. So, for example, suppose I1 is 5 by root 2 angle 0, and the same data, and I2 is equal to your what you call it, I2 is equal to, it was taken, no, that your 10 sin omega t plus 60 degree, right, this you taken. So, angle 60 degree to be, and this is a peak value. So, when you are representing by phasor, right, it will be 10 by root 2, this is the RMS value and angle 60 degree, right. So, if you multiply this I1 and I2, it is just for your this thing. So, it will be 5 into 10, 50 by 2, so 25, and 0 degree plus 60 degree. So, ultimately it will remain 60 degree, and if you divide I1 by I2, it will be 5 by 2 angle 0 degree and 10 by 2 angle 60 degree, it will be 0.5 angle minus 60 degree, it is something like this. Suppose in numerator, if you have angle theta 1, and denominator if you have angle theta 2, then this one will be angle theta 1 minus theta 2, right. So, this angle will be subtracted from this one if you write angle in the numerator, and you are what you call in the numerator, right. Now, suppose if it is given, for example, suppose 2 angle theta 1 divided by 5 angle theta 2. So, 2 by 5 is 0.4 angle theta 1 minus theta 2, right. This way you can write. Now, again let me clear it. Suppose 2 by angle theta 1 by 5 by angle theta 2. Suppose the numerator is angle theta 1 minus theta, but if it is denominator, if you want, then it will be 2 by 5, then if you write this way, if you require, it will be theta 2 minus theta 1, right. So, the way you want. So, in this case, your this case, your it is 5 by root 2 by 10 by root 2, it will be 0.5, and it was actually angle 0 degree by angle 60 degree, numerator 0 degree, denominator 60 degree, that was actually coming 0 degree minus 60 degree is equal to angle minus 60 degree, that is why it is minus 60 degree, right. So, hope this is from your higher secondary mathematics and complex number chapter, right, class 11. So, let me clear it. So, one numerical is given that you will solve it. This is one, your numerical is given, I1, I2 and I3 you have to find out. Here you will put your what you call KCL, I3 is equal to I1 plus I2, right, and accordingly you will do it. So, whatever things are given, it is given I1 is given this one, I2 is given this one, you have to find out your what you call I3, the answer, you have to find I3, here it is given, find I3 t. So, answer is given 50 root 2 sin omega t, this we will do as an exercise, right. Now, next is the steady state response of RLC circuit to sinusoidal input. So, we will consider one by one. First, elementary circuit, a purely resistive circuit. Suppose in this case circuit is purely, its polarity is instantaneous, this plus minus polarity is instantaneous, right, and in this case your voltage source V is equal to Vm sin omega t. So, in that your what you call, we have to find out IR and power loss, etc., right. So, in that case generally we write say IR is equal to V upon R, because this is the voltage V is equal to Vm sin omega t, and this is the R, it is a resistive circuit. So, it is V is equal to Vm sin omega t. So, it is Vm upon R sin omega t, and this is your is equal to, you can write Im sin omega t, and Im is equal to actually Vm upon R. This is the maximum value of the current. We are not making here RMS value and other thing right now. Now, RMS value of the current is that IR is equal to RMS value of voltage by the resistance, right. So, Vm is the maximum value. So, its RMS value is equal to Vm by root 2. So, RMS value of the current is your Vm upon root 2 divided by R. that is equal to actually Im by root 2, because Im is equal to Vm by R. So, here if you put Im is equal to Vm by R, it is Im by root 2, right. This is your what you call that your current. Now, question is that this is your V is equal to Vm sin omega t, V is equal to Vm sin omega t, right. Let me clear it again, then it will be easier. Suppose V is equal to Vm sin omega t, right. So, in this case this is no angle associated with that, it is omega t plus 0 degree, right. So, if you your what you call, if you put it in a phasor form, right. So, you take RMS value, therefore, we can write say V arrow we are putting is equal to Vm by root 2 angle 0 degree. Vm by root 2 is RMS value of the voltage, right. Similarly, current also we have got IR is equal to Im sin omega t. That means my this current is IR, this is moving like this current is IR. So, my IR is equal to, somewhere I am writing here, IR is equal to my Im by root 2 angle 0 degree, because here also no angle associated with that, both V and I are angle 0 degree, that means they are in the same phase, that is where it has been done here, they are in the same phase, both IR and V both are in the same phase, right. So, both angle 0, so both are in the same phase. Now, that means V is equal to, we can write V angle 0. So, V is the magnitude of the voltage. So, V and angle 0 means cos 0 plus j sin 0, cos 0 is 1 and sin 0 0, that is why you can write V plus j 0. Similarly, for current IR angle 0, so cos 0 plus j sin 0 degree, so that is becoming IR plus j 0, 1 plus j 0, right. So, current will be in phase with the voltage, this is the current will be in phase in the voltage, right. So, power will come next to power, right. So, let me clear it. So, in this case current will be in phase with voltage. So, and your what you call then AC circuit related by the impedance function. Now, question is that impedance functions must tell two important facts, the ratio of Vm to Im or V to I. That means, if you in AC circuit you basically will term with impedance. So, impedance will be Z, right, impedance will be Z, right. So, we will put Z bar, a complex number, is equal to, you can write either Vm by Im, this one, or is equal to, you can write Vm by root 2 divided by Im by root 2, that is RMS value of the voltage, RMS value of the current, or peak value of the voltage, peak value of the current, right. So, this is actually complex, your what you call your complex number. So, Z impedance is not a phasor quantity, I will come later, right. So, it will be either it will be RMS value by RMS value of voltage by RMS value of current, this magnitude, this is magnitude only, its angle, this is the magnitude only. So, better not to bar now. So, it is magnitude only, angle we will see later. So, it is actually either peak value of the voltage by peak value of the current, the magnitude of the impedance, or RMS value of the voltage or RMS value of the current, that is what has been mentioned here, right. So, it can be, in the case of your what you call resistive circuit, in the case of resistive circuit, this one actually only R is there, it is not impedance actually is a complex quantity, but in the case of R, this is only R, right. So, Z is equal to, we can write R plus J 0, right. So, X is not there, reactance part we will see later. So, X is not there. So, Z is equal to, here you can make Z is equal to R plus J 0 is equal to, we can write Z angle 0, because your what you call, this is your 0 and this is R. So, it is complex number, right, it is a complex number. So, generally you know that if A plus JB is the complex number, right, then this angle theta is equal to tan inverse your B by A, right, this you know. So, in that case if it is made R plus your 0 J 0, that means your A is equal to R, right, and B is equal to 0. So, it will be 0 by R. So, theta is equal to 0, that is why angle is 0, right. So, that is why Z is equal, this Z is the magnitude and Z is equal to basically R, only resistance. So, this is your, and this we represent no arrow, when we will go through it by writing errors 2 or 3, I will try to rectify everywhere. Do not put arrow, that is not a phasor quantity, it is just to represent complex number you put Z bar, it is not a phasor quantity. Voltage and current both are phasor quantity, but Z is not a impedance, is not a phasor quantity, right. So, next is, this is the notation, right. Now, next is that is here written example z angle. So, everything is written there. Now, next is the power. The impedance for a pure resistive circuit, here it will be bar only, no arrow, right. Many places it is there, this is my writing error. So, please I am rectifying it. So, this is actually r angle 0, whatever I told you, right, z is equal to r angle 0. Now, instantaneous power, because AC circuit it is time varying. So, instantaneous power P is equal to V into I, right. So, V is equal to Vm sin omega t and I is equal to Im sin omega t. So, if you multiply this, it will be Vm Im sin square omega t, right. This is thing, or P is equal to that your cos 2 theta is equal to 1 minus 2 sin square theta. Therefore, sin square theta is equal to 1 minus cos 2 theta by 2. So, here it is 1 minus cos 2 omega t by 2. So, if you do so, it will become Vm Im by 2 minus Vm Im by 2 cos 2 omega t, this you know. So, once if you done, then the average power you take P is equal to 1 upon t 0 to t, your what you call P dt, right, the average power. So, if you take average power, then this one this is actually this two, if you look at the plot, this is the constant term Vm by Im by 2, right. So, this is my Vm Im by 2 line, this is my Vm Im by 2 line, it is shown, and another term is double frequency minus Vm Im by 2 cos 2 omega t, right. So, this one is my minus Vm Im by 2 cos 2 omega t. Now, when you plot together, if you plot together this thick line, this thick line, this one is your P, right, this is the P plot. So, when you try to integrate over the total time interval, the average power, right. So, P is equal to your 1 upon t 0 to t your Vm Im by 2 minus Vm Im by 2 cos 2 omega t dt. If you just integrate this, you will get it is V into I. V is the RMS value and I is the RMS value of the voltage and I is the RMS value of the current, right. If you integrate it using that relationship, right, omega is equal to 2 pi by t, this relationship you will get V into I, and it is Vm by root 2, that is V, and I is equal to Im by root 2. That means my V is equal to Vm by root 2, V is the RMS value, and I is equal to my Im by root 2, that is the RMS value. So, basically it is a V into I, because pure resistive circuit. So, this is the power V into your I, and energy produced is converted into heat and dissipated, right. Whatever energy will produce, that will be your dissipated in the resistor, because it is a pure resistive circuit, right. So, this is your V into I. So, for resistive circuit with AC supply, V is equal to Vm sin omega t, power is equal to V is equal to P is equal to Vi, but in this case V should be RMS value of the voltage and I should be RMS value of the current, right. So, next is a purely inductive circuit, little bit understanding here you have to, I mean what I have done actually, this first taken one single element at a time, such that we will try to see our concept, how is it, right. So, next is the purely inductive circuit, So, in this case instantaneous polarity will be there, I have missed it, it is plus minus, and say it is inductive circuit is L, no other element is there and current flowing through this is IL, and polarity is instantaneous polarity, right. So, in that case we know that V is equal to L into dIL by dt, right, and V is equal to, it is given V is equal to Vm sin omega t. So, L into dIL upon dt is equal to Vm sin omega t, right. Therefore, dIL is equal to Vm upon L sin omega t dt. If you integrate, you will get IL is equal to minus Vm omega L cos omega t, right. So, this constant of integration is 0 in the steady state solution, as it is symmetrical about x axis. So, there is no constant of your of integration, right. So, it is simply IL is equal to minus Vm upon omega L cos omega t, right. So, this one IL is equal to minus Vm upon omega L cos omega t, you can write Vm upon omega L sin omega t minus 90 degree. How we are writing? So, let me clear it. So, this one, this cos omega t, you know that this one you can write minus Vm by omega L cos omega t, you can write sin 90 degree minus omega t, and this minus is there when you go the sin term, when a minus go inside it will be omega t minus 90 degree. That is why IL is equal to Vm upon omega L sin omega t minus 90 degree, right. So, this one, that means this one is equal to, it can be written Im is equal to sin omega t minus 90 degree. That means this Im is equal to actually Vm upon omega L. Im is equal to Vm upon omega L, right. So, let me clear it. So, in this case, your this voltage is V is equal to Vm sin omega t. So, let me write it here, V is equal to Vm V is equal to Vm sin omega t, right. No angle associated with that. If you put in this thing, V is equal to V, V is the RMS value, that is Vm by root 2, and it should be angle 0 degree side, right, and V is the RMS value, it will be Vm by root 2, right. Similarly, here current is equal to Im sin omega t minus 90 degree. So, this IL, it can be written as, say, IL, this is phasor quantity, say IL angle minus 90 degree, it is angle minus 90 degree, right. Just hold on, let me write here, this IL is, this is phasor quantity, right, this is RMS value, angle minus 90 degree, and IL is equal to, it is Im by root 2, right. That means it is minus 90 degree, that means, let me clear it, that means from here, this diagram I will come to later, that means this is my voltage, phasor, that is V angle 0, and current, I told you it will be here, it is written here IL minus 90 degree. So, current lags from the voltage by 90 degree from purely inductive circuit, and here it should not be arrow, it should be just Z bar, the complex number. Now, that means if we look like this, right, for example, if you look like this, V is equal to your V RMS value, say angle 0 degree, and I, right, I your is equal to IL angle minus 90 degree, right. So, this is my your this thing, then Z actually V arrow divided by your I arrow, that is whatever it is written here, right, whatever is written here, this is J, we are putting ZL, so put ZL is equal to V and this thing. If you do so, and you know that V is equal to your what you call V angle 0, right, and your I is equal to, you know, this is RMS, it is your what you call, it is RMS value. So, I your this IL is equal to your V Vm, your this is RMS value, that is Vm by root 2, and this one also, this angle is minus 90 degree, that means this is, I can make, just hold on, let me clear it, otherwise it is becoming clumsy, just becoming. So, my here I am writing my V arrow divided my I arrow, that is my ZL, right, is equal to, I can write that V RMS, right, it is V divided by my IL angle minus 90 degree, right, this is my IL angle minus 90 degree. So, V is equal to Vm by root 2, and IL is equal to, that is RMS value Im by root 2, that means Vm by your root 2, right, then this is root 2, then omega L, this actually is equal to omega L angle 90 degree, right. So, this is omega L angle 90 degree, that means my Z bar will be omega L angle 90 degree, right. So, same thing here has been made, that is, this is also put bar. So, V average is omega L angle 90 degree, little bit you do, little bit practice is required initially, right. So, there should not be any confusion anywhere, wherever Z bar I have written, it is by mistake, put simply bar to represent the complex number, because Z is not your what you call phasor quantity, it is a simply complex number, right, real part and imaginary part R and X we will see later. So, this is actually omega L 90 degree, that means for inductive circuit, that will let me clear it. So, for inductive circuit, your what you call, this is my your ZL, that means ZL is equal to your L omega, sometimes we call XL, that is the reactance of the your what you call of the circuit, only reactance, the inductive reactance L omega, and omega is equal to 2 pi f, therefore, my XL is equal to 2 pi f into L, right. Later when we solve the numericals, we will know that. So, this is actually your what you call the magnitude of the above impedance is omega L, is called inductive reactance, and represented by XL is equal to L omega is equal to 2 pi f into L. Everything is written there. Here notes actually little bit clumsy because very closely written here, but whenever we read it, if you have anything, just simply you zoom it, that is all, right. So, next is this, that means if you look into this, power will come now. Now, if you look into this, that this is my this dash line is the voltage, this is the voltage waveform, V is because V is equal to Vm sin omega t. So, it is starting from 0, and in the case of I, it is lagging by 90 degree, that is why I is starting from here, I is starting from here, right. This is I is lagging by 90 degree, and this is the expression of I sin omega t minus 90 degree, right. When omega t is 0, Im is equal to sin minus 90 degree. So, minus Im. So, here it is starting, this is your minus Im, I is starting from here, right. So, let me clear it. So, next is power. Here power graph is there, will come. First you come here. Now, so that means in a pure, that is what I told, purely inductive circuit, current lags behind the voltage by 90 degree. This we show the got it from phasor diagram. The instantaneous power. Instantaneous power P is equal to Vi in a inductive circuit. V is equal to Vm sin omega t, and we got I is equal to Im sin omega t minus 90 degree. That means Vm Im, and if you, it will be minus sin omega t into cos omega t, because it is your sin omega t minus 90 degree, take minus sin out, it will be there. So, it will be sin 90 degree minus omega t. So, that is cos omega t, that is why minus sin omega t cos omega t. So, this one your multiply numerator and denominator by 2. So, it will be minus Vm Im by 2 into 2 sin omega t cos omega t, that is 2 sin theta cos theta, that is sin 2 theta, that is why it is written minus Vm Im by 2 sin 2 omega t. This is P is equal to Vi. Now, the average power 1 to t, if you break it will become 0. This you put and integrate it, use this relationship always, omega is equal to 2 pi by t, right. This relationship you always use. So, if you made average power for inductive circuit 1 by t 0 to t p dt, it will find 0, because there is no resistor here. So, there is no question of power in that, in the purely inductive circuit, right. So, let me delete it. So, now in that case, in this case, if you look that power, this is a double frequency, right. So, if you look into that your power variation is double frequency variation of 2 omega, this is 2 omega because it is 2 omega, right. The average power absorbed is equal to 0. That means, the implication is that the inductive element receives energy from the sources during 1/4 of a cycle of the applied voltage and returns exactly the same amount of energy to the driving sources during the next quarter, what you call quarter of a cycle. It is a double frequency. So, let me clear it, come to this figure. Now, if you come to this figure, this is your power expression, this is your this thick line is your power expression, right. This thick line is the power expression. So, if it is 0, it will be t by 4, it is t by 2, it is 3 t by 4, and it is your t. I mean, that means if you take this one, this is 0, this is your what you call pi by 2, this is pi, and this is your 3 pi by 2, and this is your 2 pi, right. So, if you look into that this current or voltage, it is actually completing half cycle in between 0 and pi, right. Let me clear it for your, suppose this is 0, this is pi, and this is 2 pi. So, if you look and this point is your what you call pi by 2, right. So, whereas current or voltage, whatever it is, take for example voltage, it is completing half cycle in pi, 0 to pi, whereas this power actually it is completing your what you call complete one cycle in your what you call in pi, because frequency is 2 omega, right, double frequency. That means in what, that means this each one is a quarter, your what you call your quarter cycle. So, each part it is receiving energy, another quarter it is your what you call sending back into your what you call delivering back to the sources, right. So, one quarter cycle it will absorb, another quarter cycle it will return. So, let me clear it. So, that is what I have written here, what it has been written here, that the average power absorbed is equal to 0, that is here it is given. You please do this integration, it is simple thing, the implication is that the inductive element receives energy from the source during 1/4 of a cycle. I told you that because in 0 to pi it is completing one cycle. So, that means in 2 pi it is completing 2 cycles because it is a double frequency. So, that is why it receives energy from the source during 1/4 of a cycle of the applied voltage and returns exactly the same amount of energy to driving source during the next 1/4 of the cycle, right. And the amount of energy delivered to the this thing circuit during this. So, we will take the integration will take t by 4 to t by 2. Why? If you come to this, if you come to this, this is if we take this is 0, then this point is t by 4 and this point is t by 2 and this is 3 t by 4 and this is t is equal to, if you take this way, t is equal to 2 pi, right. So, this is, that means we have to integrate from t by 4 to t by 2, right. Therefore, right. Therefore, if we do so, the t by 4 to t by 2 and it is minus Vm Im by 2 sin 2 omega t dt. If you integrate and simplify, use this relationship omega is equal to 2 pi by 2, it will be simply half Lim square. That means half L, right, into this Im square is equal to, you can write L into Im by root 2 square. That means L into I RMS square, right. So, whatever we know that in an AC circuit, we know that energy stored is half Lim square. So, if somebody says half Li square means it is Rm peak value, not the RMS value. If you take the RMS value, it will be L into I RMS square, right. That is why it is half Lim square, right. Similarly, purely capacitive circuit, right, purely same philosophy will be applied, same philosophy you follow the way inductor, just it will be opposite, right. So, in this case, in the case of purely capacitive circuit, we know Q is equal to Cv from DC circuit analysis we have seen. So, V is equal to Q by C is equal to V is equal to Vm sin omega t, same thing we have taken, and instantaneous polarity is there plus minus, right. And that means if you take, that means IC is equal to dq by dt, you know that. Therefore, that means your this one should be Vm omega c cos omega t, right. This is the your what you call, if you take the derivative of this one, that I is equal to dq by dt. So, it will be Vm your omega c cos omega t. So, you can write sin 90 degree plus theta is equal to cos theta. Therefore, you can write this one Vm upon IC is equal to Vm upon 1 upon omega c sin omega t plus 90 degree, right. That means my V is equal to Vm sin omega t, right. That means my RMS value is Vm by root 2, that is my V is equal to Vm by root 2, right. That means my phasor notation, it will be V angle 0 degree, that means this one we can write. Similarly, for current we got Im sin omega t. So, this one in the current notation, say IC we are writing, this current is IC, we are writing IC. So, IC is equal to, we can write IC angle 90 degree because it is coming omega t plus 90 degree. Therefore, that IC actually is equal, your what you call this IC is equal to, somewhere here I am writing that IC is equal to your Im by root 2 because this is RMS value. Whenever you write phasor, it is RMS value. So, IC is equal to Im by root 2 and this is Im by your Im is given Vm upon 1 upon omega c, right. So, similar way if you proceed, right, you will get that your what you call, you will get your Z similar the way I have mentioned. So, in this case if you draw V, actually I told you V is equal to V angle then 0 degree and IC is equal to your IC angle 90 degree. So, in this case current is plus 90 degree and this is 0 degree. So, this is my reference phasor V and this is I. So, I is leading V for purely capacitive circuit by 90 degree, or other way V lags from IC by 90 degree, right. So, this is my phasor diagram, right. And similar way if you move, you will see that your ZC actually is equal to omega c by angle minus 90 degree in this case, right. For the way I have done for inductive circuit, same way you do it, you will get that means this is your ZC is equal to the magnitude, that capacitive reactance is equal to 1 upon omega c, and its angle is your what you call minus 90 degrees. So, put bar, that means it is actually 0, it is actually, forget about 0, it is actually minus j upon omega c, right, because 90 degree minus j angle let me clear it, angle minus 90 degree is equal to cos 90 degree minus j sin 90 degree is equal to minus j, and multiplied by this omega c. So, it will be j by omega c. So, your 1 upon omega c angle minus 90 degree is equal to minus j by omega c, right. This is j minus j by omega c. So, this is actually the magnitude, actually omega c is called the capacitive reactance, right. So, this omega c is actually is called that your what you call that that capacitive reactance, right, and represented by x c is equal to 1 upon omega c, and omega is equal to 2 pi f. So, 1 upon 2 pi f c. So, in a purely capacitive circuit, the current leads the voltage by 90 degree, I showed you, and power and energy, right. So, just let me clear it. So, the power and energy, the in a purely capacitive, or what you call that in your instantaneous power, same as before, P is equal to V I. If you make Vm sin omega t into Im is equal to Im sin omega t plus 90 degree, and if you just simplify this one, this one you make it, it will be Vm Im sin omega t, because sin 90 degree plus omega t cos omega t. So, multiply numerator and denominator by 2. So, it will be 2 sin theta cos theta. So, 2 is sin omega t cos omega t. So, sin 2 omega t, right. And if you take the power, P is equal to 1 upon t 0 to p dt, average power if you take, it will become 0, right. So, power variation is again is a double frequency, because this is actually double frequency 2 omega, right, and is equal to 0, because there is no resistor there. So, where power will be, there will be no power. So, average power will be 0. But if you take here also the capacitor receives energy from the source during the first quarter of the cycle and returns to the same amount during the second quarter of cycle. For example, you come to this your what you call this phase, this diagram. This is your power plot. This is voltage current. Here in the case of current is leading. That's why when this is your Im, this is your maximum one, right, current, and current is leading by 90, because it is reaching peak faster than the voltage. So, current is leading 90 degree. This is your IC is equal to your what you call the peak value Im, that is Vm upon 1 upon omega c, and power is the double frequency. So, if it is 0, it is T by 4, then T by 2, and so on, right. So, same philosophy. So, current in your what you call in 2 pi it will make 1 cycle, but in 2 pi power will make 2 cycles, it will complete 2 cycles, right. So, in this case if you do this 0 to t by 4, that is only quarter cycle, 0 to 2 by your what you call 4 Vm Im by 2 sin 2 omega t dt. If you integrate this, it will become half C Vm square. You know the store energy in capacitor we have studied in DC, half C V square, it is becoming half C Vm square, that means half C Vm square, right. That means this one can be written C Vm by root 2 square, that means is equal to C into V RMS square, right. That means in AC circuit, whenever you talk about up for your CV square, means your V is the peak value, right, or you have to make C into V RMS square, that is the energy stored in AC circuit, in a capacitive circuit, right. So, this is a purely your capacitive circuit. So, what we have learned, that for purely resistive circuit, power absorbed is, we have seen that is V into I, right. In the case of a purely inductive circuit, power absorbed is 0, average power absorbed is 0. Similarly, for capacitive circuit, right. But energy in the pure inductive circuit, it will be half L Im square, and for the capacitive one, it will be half C Vm square. This integration is very simple, you can do yourself, but all the time you will use this relationship sorry, omega is equal to 2 pi by t. This relationship you will use, right. With this, thank you very much. We will be back again.